Hi guys, this video is going to tell you what is imaginary numbers. So first, let's try squaring some numbers to see if we can get a negative result. No luck. Always positive or zero. It seems like we cannot multiply a number by itself to get a negative answer. You will never be able to find a real number solution to the equation x squared equals negative 1. It seems like it is impossible to square a real number and get a negative answer. But now imagine that there is such a number that could do this. I times I equals negative 1. Would it be useful, and what could we do with it? Well, by taking the square root of both sides, we get this. I equals square root of negative 1, which means that I is the answer to the square root of negative 1, which is actually very useful because by simply accepting that I exists, we can solve things that need the square root of a negative number.
So I represent the unit imaginary number, which is same as 1 for real numbers. In mathematics, we use I for imaginary number, but in electronics, we use J. Because I already means current, and the next letter after I is J. As a conclusion, the following is true for the number I equals square root of negative 1. I squared equals negative 1.
What is imaginary numbers and complex numbers? The definition of imaginary number is when an imaginary number is squared, the result is negative. For example, I squared equals negative result. The definition of complex number is imaginary numbers had become most useful when combined with real numbers to make complex numbers like 3 plus 5i or 6 minus 4i, which refers to the diagram below.
Then, how to solve an imaginary number question? Here is an example. We have to simplify square root of negative 18. First, we notice that square root of negative 18 is an imaginary number, since it is the square root of a negative number. So, we can start by rewriting square root of negative 18 as I times square root of 18. Next, we can simplify square root of 18 using what we already know about simplifying radicals. After simplification, the solution for square root of negative 18 is equal to 3i times square root of 2. Not only square root of negative 18 is an imaginary number, there are some other examples of imaginary numbers like I, 12.38i, negative I, 3i over 4, 0.01i.
So why are they called imaginary numbers? These numbers used to be thought of as non-existent, hence the word imaginary. Although now we have concluded that these numbers do exist, we still call them imaginary. The word imaginary was meant to be downgrading for these numbers, because at a certain point in time they were deemed useless. Even after imaginary numbers were concluded as important and useful, mathematicians decided that it would be best to keep that name. Who first discovered imaginary numbers? Greek mathematician and engineer Hieraeus of Alexandria is noted as the first to have conceived these numbers, but Raphael Bombelli is the first to set down the rules for multiplication of complex numbers in 1572. The first person to actually call these numbers imaginary was René Descartes. He used this term in his book entitled La Geometry. The word imaginary was intended to define these numbers as demeaning. But the use of imaginary numbers was not widely accepted until the work of Leonhard Euler and Carl Friedrich Gauss.
The Euler formula. This equation has gained particular fame in popular mathematics because it involves all the fundamental constants in mathematics. 0, 1, e, pi, and I. Euler himself inscribed the formula on the gates of the Royal Russian Academy of Science.
The uses of imaginary numbers are cool too. First, the spectrum analyzer. Those cool displays you see when music is playing, complex numbers are used to calculate them, using something called Fourier transforms. In fact, many clever things can be done with sound using complex numbers, like filtering out sounds, hearing whispers in a crowd, and so on. It is part of a subject called signal processing. Second, the imaginary numbers can also be used in electricity. The alternating current electricity changes between positive and negative in a sine wave. When we combine two AC currents, they may not match properly, and it can be very hard to figure out the new current. But using complex numbers makes a lot easier to do the calculations, and the result may have an imaginary current, but it still can hurt you.
Some interesting things about imaginary number. The property of imaginary numbers. The unit imaginary number I has an interesting property. It cycles through 4 different values each time we multiply. I equals square root of -1. I squared equals -1. I cubed equals negative square root of -1. I to the power of 4 equals +1. Then back to 1 again. I to the power of 5 equals square root of -1, etc. In an imaginary fraction, it actually matters whether the numerator or denominator has the I in it. For example, 1 over I. Although I is an imaginary number, I to the power of I is 100% real.